Okay, so today we're going to be talking about simplifying radicals. And last year, you guys did see this. However, speaking to my first hour, I believe that there were some pieces that, I don't know, you still may struggle with. And so if you've got additional questions, please come talk to me. I will kind of put this out to you guys. And um, I think that the big thing is if you've got a square root, it means what times itself makes that. And so if you know the square root, take it and put down the answer. So if I ask you, hey, what's the square root of 16? You'll tell me 4. And so on the other hand, if I ask you a square root that you don't know, well, look to see, is there a perfect square factor who goes into it? And so the square root factors that you know would be like the square root of 4, the square root of 9, the square root of 16, the square root of 25, square root of 36, 49, 64, 81, 100, 121, 136, or 169, 196, 225. Those are all perfect square factors because they are perfect squares when you take them. So this is 81 here. But the thing is, if you don't know the square root of something, look to see, is there a perfect square factor who divides into the radical by which you could break it down? And so I think the big thing would be the square root of 52, I don't know it, but the square root of 4 divides it. How do you know? Well, take 52 and divide it by these numbers, and the biggest one that divides into it evenly is the one you go with. If there isn't anything that divides into it, well, then don't divide it by anything. And so you wouldn't want to just say what factors were, because like the square root of, say, 40, you could write 2 times 20, but you don't know the square root of 2 or 20. Okay, so you want to pick something you know the square root of. So like you would go the square root of 4 and the square root of 10. The square root of 4 is 2, the square root of 10 I don't know, nor is there a perfect square factor who goes into it. So you're looking to break down these radicals by either taking their square roots or looking for a perfect square factor who goes into it. Okay, those are the two things you're looking to do. And so, and the principle we use is that if you've got the square root of something, you can break it up into the square root of each factor. Okay, so that is a property that we are allowed to use. And I wouldn't do this here. I mean, it's true, but I wouldn't break square root of 30 into square root of 3 and 10 because in truth, that's not going to help you to break it up. So I would mostly go from here to here and be like, okay, the answer is square root of 30. And no perfect square factor goes into it, so I wouldn't break it down any further. Okay, so breaking down radicals is going to be something that we do. Another thing is you're not allowed to leave a radical in the denominator. So if you see a fraction underneath a radical, you can break it up into the top and the bottom. And if you know their square roots, then you can take them. Okay, that would be completely fine. Another thing is called rationalizing denominators, okay? The difference between rational and irrational, we use rational a lot versus irrational. Rational means an integer, okay? A positive or negative number, a decimal that ends or repeats. But the thing is, on the denominator, we want the number to be an integer, okay? We want it to be a number. We don't want it to be a square root. And so what you do to make the number in the bottom to be not irrational, not a square root, you can multiply the top and bottom by something so that your denominator is not irrational. And so an example of that would be if you've got like 5 over the square root of 2, well, the square root of 2 is irrational, so you're going to multiply through by something so you know the square root of the denominator. If you multiply the square root of 2 over itself, like that's a 1, you would get the square root of 2 times the square root of 2, which is the square root of 4, which is 2. You can multiply top and bottom by any number other than 0. You can't do it by 0 over 0. That's weird. But you can multiply by the offending radical so that you know the square root of the denominator, and then multiply the top by the same thing. So 5 times the square root of 2, you get 5 square root of 2, and you look to see, does the coefficient reduce? So 5 over 2 doesn't reduce. You don't reach underneath the radical and see if the 2 reduces. No, that doesn't work. Look for the coefficients to see if those simplify with each other. You can also look to see, does the radical break down? Okay, so that's another factor to look at. But in class, I had kids do another question. I was like, okay, try this one. What if you have, 3 over the square root of 8? Okay, What would you multiply top and bottom by so that you know the square root of the bottom? Well, I would multiply the top and bottom by the square root of 2. Why? Because you get the square root of 16, who is 4. Okay, and so on the numerator, 3 times square root of 2 is 3 square root of 2. Again, look to see if the coefficient reduces. And so on the bottom, I had kids practice, saying, can you multiply these? Can you reduce these fractions? Can you rationalize the denominators? And these are things you've seen from last year. We've done some of them already this year, like the first one. Do you know the square root of 500? Well, no, not at all. And so the question is, do you know any perfect square factors who divide into it? Well, the biggest perfect square factor who goes into 500 is 100. So it'd be 100 times 5. Always put the one you know first. So the square root of 100 is 10. And so this would be 10 times the square root of 5. Okay, so that's how you break down the square root of 500. The second one, the square root of 80. Now there's two ways to do this, the slow way or the faster way. The square root of 80, and the question is, do you know any perfect square factors that go into it? So the fastest way to do this would be to say 16. So 80 divided by 16 is 5, so you put 16 times 5. The square root of 16 is 4, and then you get the square root of 5. That's the fastest way to get to the answer of 4 radical 5. Now, if you didn't see that, you might have started with 80. Now, don't do 8 times 10. Why? Do you know the square root of 8 or the square root of 10? It's true, but just not going to help you break it down. One of the factors you do know who goes into it is 4. Say that you went with 4 and 20. Does 4 times 20 make? Yes. And the square root of 4 is 2. 2 radical 20 is true, but we're not done. Do you see any perfect square factors who divide into 20? Well, yeah, of course. The square root of 4 times the square root of 5. Okay, square root of 20 can be broken down using a perfect square factor. The square root of 4 is 2. So the question is, what do you do with these 2's? Is 2 times 2 times square root of 5 or 4 square root of 5? That will be our answer here. Okay, so when we multiply, we want to, and I should put another problem kind of up here so you can see. If you've got like 3 square root of 2 times, say, 5 square root of 8, okay? Actually, 8's a bad number. Let's do a 6. The question is, when you multiply the front, you multiply the number coefficients and you get 15. When you multiply the radicals, you get the square root of 12. And that's awesome, okay? However, if your square root has a perfect square factor, you should break it down. Notice that the square root of 12 has a perfect square factor of 4 and 3. So it's the square root of 4, square root of 3. So it'd be 2 radical 3s. So what do you do with this 2 and the 15? Well, you times them. So 15 times 2 gives us 30, and you bring down the square root of 3. And so multiply the number factors, multiply the radical factors, and then break down the radical as you can. Okay, and so what I want you guys to look at on this first question here would be when you multiply these radical factors, you're going to get the square root of 90. Okay, there are no number coefficients other than like 1. So square root of 90 is what you get when you multiply these together. And so I think the big thing would be, does this break down? Well, of course. Is there a perfect square factor who goes into it? And that would be 9 times 10. Square root of 9 times square root of 10 makes square root of 90. You get 3 radical 10 for your answer. Okay, so that would be the answer for number 3. Now, the next question would be, if you're multiplying number 4, you multiply 5 by the coefficient in front of the second group, which is going to be 5 times 1, which is 5. If you multiply the square root of 2 times square root of 2, you get the square root of 4. Well, the square root of 4 is 2, and then you multiply by 5, and you get 10. So when you multiply the radicals, see, can you break them down? What's going on with those? What do you get? On the next side, I would say let's start with number 7. And let's look at square root of x times square root of x, and that's going to be the square root of x times x is x squared. Well, what is the square root of x squared? Well, the square and the square root undo each other, and you just get plain old x. Okay, so that's kind of a cute question. Number 8, well, you can 5 times 3 is 15. Square root of 2 times square root of 6 is square root of 12. Okay, this looks like the question we did on the front. Break down the square root of 12 into the square root of 4 times the square root of 3. The square root of 4 is 2. Bring down the 15. Those are related by multiplication. And you get 30 square root of 3. think it is the same question as the front sheet. But multiply the number of factors, multiply the radical factors, break down the radicals. If there are a number of coefficients, then put them as their coefficient there. On the one below, it says square it. Well, that means multiply this thing by itself again. So 3 times 3 is 9. Square root of 2 times square root of 2 is square root of 4. The square root of 4 is 2. 9 times 2 gives us 18. Okay, so that's a good question. The following two questions talk about rationalizing denominator. You're not allowed to leave an irrational value within the denominator. So let's multiply top and bottom by that radical that you see in the bottom, because you can multiply any fraction by 1. When you multiply, the top by 1, by square root of 2, you get the square root of 2. And then square root of 2 times square root of 2 is the square root of 4, which is 2. And so that's your answer to this question. On number 6, you can't have a radical in the denominator, so timesing top and bottom by that offending radical in the bottom. Multiplying the numerator, you get 3 radical 3. Multiplying the denominator, you get the square root of 9, which is 3. Look to see, do the coefficients reduce? And these coefficients do, so you end up just with the square root of 3. And the last one, we're looking to say the square root of 7 over the square root of 16 is what this breaks up into. And the square root of 16 we know is 4. So you cannot leave a radical in the denominator, and you don't have one, okay, when you're done. So let's scooch this down. A Pythagorean triple means all 3 sides are nice numbers. And here are some examples of some of those Pythagorean triples. And so as you do the Pythagorean theorem, if all 3 sides are nice, then you're going to have a Pythagorean triple. Now, one thing we've talked about in our classes today is, how do you do the Pythagorean theorem? Well, the 2 legs are going to be the sides that meet at the right angle. You've got 2 legs, they meet at the right angle. And so to get your Pythagorean theorem, you go x squared plus 4 squared equals 12 squared. The legs that get squared and added together are going to be the sides that meet at the right angle. And so you get x squared plus 16 equals 144. Minusing 16 from both sides, you get x squared equals 128. To get plain old x, you take the square root of both sides. And you're like, that's not very nice. Well, yeah, it's going to be the square root of 64 times the square root of 2, or 8 radical 2. This is not going to be a Pythagorean triple because all 3 sides are not integers. And so this is not a Pythagorean triple. If you look at the previous one, the numbers get pretty enormous quickly, but the 2 legs are the 14 and the 48. The 2 legs meet at the right angle. Okay, so the 2 legs meet at the right angle. 14 squared and 48 squared equal x squared. If you square each of those and you add them together, you're going to get 196, and you're also going to get 2304. And that's going to give you 2500 equals x squared. Square root both sides, you get 50. Okay, so that means that it is a Pythagorean triple because all 3 sides are integers. So that's kind of cute. And so on your homework tonight, they're going to ask you, hey, can you do the Pythagorean theorem? Make sure you do the leg squared plus the other leg squared equals the hypotenuse squared. On the next question, they tell you a scenario, okay? And they give you the diagonal. I'm going to change this to be 20 centimeters. And they say the ratio of the length and the width is 3 to 1. Does that mean that the length and width are 3 and 1? No, that means they are 3x and 1x. The ratio is going to be 3x and 1x. And so the question is, how do you do the Pythagorean theorem? Well, you do 1x squared plus 3x squared equals 20 squared. Again, I changed that from 12 to make it 20, just to make the numbers a little cuter. How do you square 1x squared? Well, you take 1x times 1x, and you get just x squared, or 1x squared. 3x times 3x gives us 9x squared. And then that equals 400. We're going to have to put your big kid pants on. X squared plus 9x squared is 10x squared. Think about, how would you solve that? Well, divide both sides by 10. Okay, divide both sides to get rid of the 10. You get x squared equals 40. And then to get plain old x, you square root both sides. So you get x is equal to the square root of 4 and square root of 10, or 2 square root of 10. So that means that if you go back and fill it in for the sides, 1 times 2 squared root of 10 is 2 squared root of 10. And then if you do 3 times 2 squared root of 10, that's going to be, multiply the number of factors, you get 6 squared root of 10. So those will be your two sides. Not very lovely, okay, and they're in centimeters, but that's going to be what we look for, is can you write something using, let's see, the ratio, okay? Can you do the Pythagorean theorem even with x's? Can you kind of find these answers here? The last one, the numbers get kind of salty, okay? They just do. And so if you draw this, you're going to have the ratio of 16x and 9x, 16 to 9. And that's going to be the width to the height. So this is width, this is height, okay? And then also the diagonal is 42. So you're going to do 9x that gets squared and the 16x who also gets squared, and that's 42 squared. So this is 81x squared plus 16 times 16 is 256 x squared equals 1764. Combining my terms here, you're going to get, this gets disgusting. I'm just not going to lie. Equals 1764. Divide both sides by 337. You get x squared is equal to 5 point something, like 5 point, I don't have it written down, 5.5-ish. And then you take the square root of both sides and you get x is approximately 2.3. And so you could times 9 by it to get the one side, and you could times 16 by it to get the other side. And those would both be, it looks like, in inches. So being able to say, yes, this is the hypotenuse. Yes, the ratio is 9 to 16x. Okay, can you square each of the legs, add them up, and then solve the equation to get the value for x squared and then getting x, and then could you plug it in to find out those values? All right, thanks. Have a good day.